That got Dave good. Okay, we're recording. Sorry, we're all set. Hi, everybody. Pace Ellsworth here. I will be your instructor this evening, and we are going to be talking about some more JavaScript. This is going to be our last week together. Oh, so sad. I hope that everything is sinking its way in. If you're still having trouble with figuring out why we do closures, if we're ever going to look at them ever again, it's definitely kind of more of a concept. You don't have to worry too much about it. It's more of just pay attention to your variables, right? Pay attention to what are you telling your function? Are you telling it gibberish? Are you speaking to it in Generation Z, or can it understand you? And then it's like, no offense to all the Gen Z people in here, but just don't give it jargon, right? Don't give it things that it doesn't understand, and don't type anything. Your code is thinking hard about what you are typing and wants to understand you so it can give you good answers. So last week's lesson was be nice to your code. Before that, callbacks, array methods. Array methods are definitely a little bit tough to understand, especially since you're passing functions inside other functions and you're like, where's this line of code and when does it get called? And then understanding that the default array methods are actually callback functions is not something that's super intuitive because it's kind of built into arrays, right? You're not defining that higher order function, it's defined for you. So that's something that we're going to learn about. We're going to understand a little bit better today. How in the world can you have this function that's built into arrays? Well, it's because arrays are actually objects. At least their prototypes are. So prototypes are basically the skeleton of any data type in JavaScript. It's kind of like, what is the spirit of this item, this data type? Like, what are the possible things that it can do? And that's why it has certain properties, and then certain properties that are actually functions, and those are called methods. Okay, so we're going to learn all about that today. Here are the notes. Let's do prototypes. And it says prototypes and inheritance, but what's funny is that we're going to mention those not as much as we're going to mention the this keyword and constructors. So it's that's really what the actionable part of this is, the actual stuff that we're going to work on. We're going to learn these two new keywords today. One is called this, and one is called new. So this new keyword we're going to learn is this, and the other new keyword is new. So that's not confusing at all. You already fully understand it, which is very good. I'm glad. Thanks. Now class is over. So I'll go ahead and post these links right now. I should have put them in there. Here they are. All right. Yes, JS6, prototypes and inheritance, and go. I believe that is all. I don't think there's anything different with that final project. Let me just verify that real quick. Let's see. Nope, that's exactly the same project at the end of class, so we are good there. All right, let's do. And then here's the, if it's not already pinned, that is the link specifically for questions. And then let's do a little bit of a project review. So let's do a project thread. Ooh, since I switched to dark mode, so many of these emojis don't look as good because they have a white background on them. Okay, so please, the project that you did for this last class, go ahead and post it in the project thread, and we're going to do some review. Let's take a look at it, see what we can learn, try to understand these closures, and go from there. So I don't see them yet. Go ahead and put them in replies. Somebody willing to share. Hot tip, everybody should do it. If you're done with that project, the one for JavaScript, let's call it 4, scope and closure, go ahead and reply and put something in there. So we have something to review. Yes, thank you, Anna. Okay, I'm gonna go ahead and share my screen. And yeah, so yeah, we're almost done with all of this. We're getting so close to the end where we're going to be reviewing all of JavaScript and then getting ready for this build week where you're not going to do any JavaScript. You're just going to do HTML and CSS and less. And then you'll get to this JavaScript assessment at the end, which is a nice review. It's going to be primarily a review of array methods. So you don't need to focus on absolutely everything. You can look at basically ifs, if loops or statements and control flow. Just look at array methods or any other type of for loop, basically, and you could and you're mostly good. Okay, so but we'll get a good preview of what the structure of that JS assessment is going to look like. It's basically going to be in this cool thing called Code Sandbox that you may or may not have used already. I believe some of the new projects for last week were probably in Code Sandbox, if I'm not mistaken, or for last sprint. But yeah, here we are now. We've got, and let me know if how my sound is and everything. We good on sound? Yeah? Okay. Everybody seems crazy tired, and I think it's because they got the Mondays. I got a little bit of the Mondays too today. But here we go. Scope and closure. What did we learn here? Okay, we looked at what is the idea of scope, all right, and what is the idea of closure? How do those relate? It's and then there was this scoreboard and some randomly generated data, and how do we take this and make something of it? Okay, so let's take a look at the index.js here. All right. So we have a counter maker. Okay, we got counter 1 and counter 2. What are the differences? Okay, count in task 1. Okay, so task 1. I see. So this is the difference between these two codes, counter 1 and counter 2. And we looked at this. What is the big difference between these two methods here? So in the project thread, go ahead and give me some thoughts. Where is count? Which scope is it in? Is it in a function scope or a global scope for counter 1? Yeah, so that's in the function scope. Okay, so that means that it is within what the function can see. Okay, or in other words, also what the variable can see is only, and what it has effectiveness on. Where it can do its actions, it's only inside this function after it's been initialized. Whereas with this one, counter 2, where is count? What scope is that on? It is on the global scope. You can think of these kind of as really the same concept, and really it's just, what's the global scope? Well, it's kind of like one giant function, but easy just to break it down into those two categories. If it's not inside a function that's been written that you can see, it's in the global scope. It's on the window at large. And if it is inside a function, then it is limited to that function only. And really, the let is limited to a specific block of code. Okay. All right. So those are the two big differences. Why would we use counter 2? Where would that be beneficial? I'd like to see some thoughts about that. What's the big reason why we would use that? Because you might want to sometimes. Could it be useful to sometimes? Yeah, when if you have to reuse that count, or if it's only at the start of its journey, picture it's like this hero on a quest and it has a lot of places to go until it's done with its journey, okay? It might be transformed many times. And this happens a lot, for example, if you have, some kind of input data that's really raw and it needs to be formatted in a lot of different ways before it can end up, for example, in like a chart or something. So you could have a lot of work that goes into a global variable and just it goes down a whole assembly line, okay? But if you don't use that variable elsewhere, what do? You typically, if you have a single use variable, you want that to be contained inside whatever function you're working on. So so it only does its job and then it disappears. It's not cluttering up the memory of the program. Okay. All right. So write a function called inning. Okay. So they declared a function that generates a random number that points to a number of points that a team scored in an inning. All right. So it went ahead and did that and used math.round, math.random. Great. Remember, you have floor and ceiling too that you can round down or round up, force it to go one way or the other instead of just the regular rounding. But this is great. And then final score accepts a callback function inning from above and a number of innings and returns the final score of the game. Okay. So passing in a callback function for this final score and passing the inning number. Okay, we're gonna take this callback function times the result of that callback function by the inning number, and that is looks like that's going to be the home team's score versus the away team's score. Interesting. Okay, so and then it's going to pass this inning. It's going to pass this inning function in as the callback function, and that inning function is the one that was defined up here. So it's going to pick up just a random number. And let's go ahead and, all right, so now we go down to here. So there's an example both using callback and closures. Now scoreboard, let's make a scoreboard function that accepts two parameters, a callback function and a number of innings. Okay, and so we have here's an innings array, okay, 1 to 9, that makes sense. There are only 9 innings in a regular baseball game. I went to one where it was tied at the end and it went for a long time. All right, now this one, here's the return value, but all this is doing here, okay, it returns the score at each point in the game. So at each inning, it should return the current score. So it's going to take a callback function, and we're passing it, looks like scoreboard, we're passing it the inning function again, and then also the inning array is getting passed into this inning num. And then score by inning, okay, initializing a new empty array, totally cool. What's the drawback here? Unless you need that var, then let's keep it a let, okay? All right, and then inning num for each. All right, great, using a for each, passing those in, and for each one, just console log testing that, and then, all right, let the away team score equal the callback times the value, callback times inning number. So does this, yeah, it isn't being used as there might be an issue here that might not be being used as a callback in the way that we expect it to. So, but yeah, I mean, so you get the idea of the structure that you need to have though for these. Initializing certain parameters, and then return the score at each point in the game, like so. So instead of a callback, looks like you needed to probably build in a closure architecture instead. Okay, so this one explicitly states you need to have it as a callback, but the last one isn't really clear, is it? All right, so let's see if we could jump into, I want to just compare it with Nathan, if that's okay. I'll jump into yours and just take a look here. Okay, so let's just see. Oh, interesting. Okay, so traditional for loop in here, and we have, okay, so we have the home team scores, away team scores, a for loop here for the current inning. We want to push the result of inning to each of these new arrays, and then got fancy with the ths and the sts and the ns and the herbs. That's cool. Nice, nice case when and break. Nice use of break. Break, in case you didn't know, break is this cool keyword in JS where you can basically jump out of a function or jump out of a loop and not return anything. Just say like, all right, I'm done. So it's a nice little way to just get out of a loop, especially with loops. Very helpful. You know, good to have some kind of a break in there so you can prevent you know, just a continuous loop that goes on for too long. All right, so continue statement is interesting because it'll break the current iteration in the loop, but it will continue to the next iteration in the loop. Break just breaks the entire loop. So so yeah, those are interesting differences, but very good to know actually. So I'm gonna go post that. Nice use of that case and break. Okay, but yeah, return the inning suffix, inning, the current index of away team scores and the current index of home team scores. And then you get the final score at the very end of the game. Okay, great. So definitely a good example of nesting functions inside other functions, which is what we're trying to do with closures, returning other functions or just calling them inside of other functions. So great. Definitely, if you felt like it was a little bit tricky just to kind of get what it was trying to ask, then go ahead and reply to the project thread or just put a react on the project thread if closures were just kind of a little bit confusing for you. It's no shame at all. It's something that we went over, but it was more of a concept really than this fantastic new skill. Um, callbacks are a little bit more straightforward because everything's kind of named in its own place. There's less anonymous stuff going on. But yeah, it's good to get those out of the way. This week is going to be pretty cool. You're just going to focus on this one general idea. It's that everything in JavaScript is an object, and that we can kind of modify those objects however we choose, however we see fit. It also really cements in here this idea of inheritance we're going to get into today and have a lot of fun with that. All right, so let's look at the schedule. Thank you for sharing. All right. Yeah. So let's we did the project review. I want to take a little bit of time to just show you the debugging tool. That sound good? Like, let's look at some of those dev tools in Chrome, and you can look at these in Firefox or Brave as well, and learn a little bit about how to kind of check your work and debug issues on websites and things. So let's look at that, and let's just spend a little bit of time on that, and then go for a break, answer any questions, and then get to the meat of the day. We're going to learn about the this keyword. The this keyword is a funny little thing that you've looked at a little bit, but it's a fun thing. So we'll get into that and learn all about why it exists and how useful it is really in pointing to making objects and giving objects new properties. So it's a nice little thing. Okay, with that, let's just jump into this little exercise. So this is the developer. I'm going to do a little debugging thread. And I'm going to ask you to be as active as possible on this. So basically, this is just a nice little, I'm just going to post it in reply to that. This is a nice little tutorial about how to use JavaScript to fix a bug on a website. So let's open this demo. Notice we have this supposed calculator here. What if we do 20 and 20? We should expect 40, right? That's 40. No, it's not. So there's a problem in here. What is it probably doing? In reply to the debugging thread, what do you think it's probably doing wrong here? Because it looks like it's doing something other than addition. It looks like it's concatenating strings. Yeah, that's right. So if it is treating this like a string and that like a string, and thus adding those two together to get 2020, that's a problem. All right, so let's see if we can fix this. So let's figure out what's wrong with this button here. And you know what, let's go put this on the right side. And I don't need that. Right. Oh, wait, did I put it on the left? Who puts it on the left? Weird. Not me. So let's look at the sources. All right, so we've got a few things in here that you've noticed before. Elements basically covers the HTML. This styles section shows you the regular properties that are assigned in the CSS. Computed focuses on that box model and kind of the resulting actual real values of all the properties for that box. Okay. And then we're going to have this thing called console. And console we can get the window. We can find specific items on the page using the console. We can just do straight JavaScript in this console. We can just say let new calc equal 5 plus 10, and then we can just state it. New calc. See, we can just say it, and then boom. We can do some regular JavaScript here in the console. But another fun thing that we can do with this is we can use sources. And let me zoom in on this because that's a little bit small. Is that a little bit better? It's probably a little bit better. Now we can do a nice little thing called an event listener. So with event listeners, and you can also do specific breakpoints in this and play with them. We're going to find this function that happens that when we do this right here, we're going to find the function, and then we're going to just kind of work our way through it. Here's the specific function that handles the math that's in here. So let's review. Let's just review this right now and see what we can learn from it. Okay, it should be enough space right there. We could pretty print that, and yeah, we should be okay. All right, so what's going to happen? All right, on click, so that's just going to say once we've clicked this, it's going to check first, are the inputs empty? Okay, if they are empty, then it's going to push us a label that says error, one or both inputs are empty. All right, I can't do my math because I don't have two values, I need at least two. All right. If that's the case, then we'll update the label with that new error message. And we can test that ourselves. So we leave that blank, and we click that, we get this error. One or both inputs are empty, okay? Not good. All right, so we're back to the beginning. But we can also go in here and see, all right, once once it checks after, so this is where it checks if they're both empty. And if they're not both empty, then it will return false. And then, or if they are both empty, it will return true, and then it will give you the error message. If they're not, if either one of them is empty, it will return false, and it will just move on with the code. All right, so update label is the next thing that gets called once you click. What is it going to do? All right, it's going to get number 1, and then get number 2, and then what? It's going to sum these together. So this plus would be addition if it were numbers, but it would be concatenation if it's strings. Okay, so let's see what's going on here. If this one is just returning the input of this right here, then let's try to find out what's going on in here. Okay, so what's going to happen if we get this input? Let's just go to sources and then breakpoint. And here's how we do one of the breakpoints, for example. Let's do one on a click. Let's try that. So let's just click here. All right, now what's happened is something very interesting. We are now stepping through the functions, okay? Because I put that event listener in there that said, hey, whenever I do a mouse click, then stop the code and let's walk through the code step by step. You now have these options right here where you can resume the script and it will just skip to the end, or you can step over to the next function, step into the next function, step out of the current function, just move to the immediate next one, or just do step by step. And by step, it'll basically take it line by line of code that it executes, okay? We don't need this onload WFF, so let's just skip past that one. And let's just wait until we get to that getstarted.js again and see what happens, okay? All right, so getstarted.js, here we go. Now we're just gonna step through slowly. All right, so it does if inputs are empty. Now it goes to inputs are empty, checks that. All right, and then it, now we're gonna get number 1. And let's step into this here, get number 2. All right, it sees that they're not empty, first of all. Now it goes to update label. Now it's gonna go in here. Now let's watch what it does really closely. All right, it does get number 1. Return the value. Hoo. What do we see here? This is a nice little thing. There we go. What do those look like? What are those values that are being stored in there? Are those numbers? Are those floats or digits or decimals? No, those are strings. Yep, because they've got little little quote marks around it. So how are we going to fix that? All right. It explicitly knows, all right, we concatenate 2 strings together. What are we going to get? A longer string. How do we fix this? How do we do this? All right, so let's go ahead and cancel out of the script execution. And let's try to fix it. Okay, let's go to here and let's try to fix it. So let's go. All right, so there are a couple different ways we could do this. We could change them right here. We could change them right here. Or we could change them right here. So all kinds of ways we could do this. What if we changed them right here? All right. Now, okay. What are the, okay, I almost gave it away. Parse int is one way we could do this. There's another one too that you could do, and it's just called number. View number. Let's try parse int. Okay. Yeah. Let's try that. Parse int. Okay, so if you're not sure what that is, let's Google it. Let's take a peek. So parse int is a function that pretty basically parses. In other words, it kind of looks at it piece by piece and converts it, translates it from a string to an integer. All right, so that's what's going down. Let's try this, see if we can save it. All right, I've saved my version of it. Now let's try and see what happens with that. Let's get over to our get started. Okay, Now let's step through it piece by piece. They're not empty, yay. Now we go to update label, and then, oh, wait, no, this isn't the right one. I know I've done this before, where it actually saves it and then we can run it like appropriately. Might need to refresh the page. So it should work. Worst case, what we're going to do is go to the tutorial and see how they do it. But right here, okay. All right, so now let's see what happens. All right, let's try this one more time. We still have this mouse click there. Oops, you know what, let's turn this, I don't want geolocation and I don't want load. And I'll take the mouse off for now too. Let's continue with the debugging process and let's do something a little bit, let's just do something else. Okay, 1921. All right, this should also add to 40, but it should be 1921 instead. Obviously, oh, what? It works now. All right, let's try it. Let's fix it. Let's see what we fixed. Let's step through it now. Now that we've fixed it, let's step through it and see how we did that. Okay. So let's walk through. Let's walk through. Here we go. Okay. So it saved the code that we edited there. Let's just step through it and see how it does. Now we're in the update label function, get number 1. And it's still passing strings in. So we didn't, because remember, we didn't change it at this point. We didn't parse int down here. We could, that'd just be different, okay? We're gonna parse int down here, and then what do we get? Sum 40, okay? And then we're done, okay? So then we take addend 1 and addend 2, sum them together, and you get the text content of that, which is what you should expect down here. 20 plus 20 equals 40. Okay, so that's just a quick whirlwind tour of the debugger, just to show you what it can do. Mouse click and mouse down are kind of some of the more common event listeners you can do, but you can also do it. You can also do neat things like say, okay, I want to break on these 3 lines. So you could just put those breaks in there, and then it will listen. So let's try, for example, let's just break on this one, right? There we go. Let's just try to break on that and see what happens. Okay. There we go. So one way to skip to the end is just put a single breakpoint in, so you don't have to wait and go through all of the other just bloated JavaScript that's built into the page. I just set a breakpoint right here just by clicking directly on the line in the specific file that I wanted to break. And so I just clicked right there, and guess what? It stopped. And then I can step through and continue on with the code. Okay. All right. So should have been software. That's funny. So are we good on debugging? Obviously, there's a lot more here that we could take days to go through, but you don't have to worry about that right now. But are we good on the general concept? Just give me some reacts on the debugging thread on the post and just say, yeah, thank you. I'm glad that we know that there is a way that just using the browser, we can kind of test not just different HTML and CSS, but test different JavaScript. It's a nice little skill to have, to not just have to think, oh, dang it, I'm gonna have to like download this page and open in VS Code and then go from there. No, you actually have the power to you actually have the power to use these options here in the dev console, and it's very similar on Firefox too, to break it at certain points, or to just take a look at one thing and try to get it right. Okay. All right. So with that, I'm going to go to a break, and we will come back in 5 minutes and feel great. So we are just right on time for that break. 5 minutes starting now. Turn your mic and video off and just stretch. Back on. 0. Oh, we're back. Hi. All right. So let's take a look at the schedule. We accomplished our break times. We are going on to questions. And then we're going to talk about this keyword, break, and then talk about constructors, and then we'll be done. So let's look at all these questions. There are absolutely many of them. They're pouring in. You guys have no questions. That's I appreciate that. But if you have any, then post them. Okay. All right, so let's go ahead and back to here. And now let's get to the this keyword. Oh, the this keyword. And why do I say it like that? Because if I don't, it's going to be way more confusing. So let's do thread, the this keyword thread. So what is this? All right. Jump in that thread and then tell me what this is. Not in JavaScript, but just in general. What does it mean? And then what we're going to do is jump into this link here and learn a little bit of it from W3 schools. But before we describe what it is, just tell me in your words what it is. Okay. So Anna says it's a reference to something already mentioned or understood. Yes, it's and there's a specific word referring to it. What is this is a type of word. It's a class of words in English that is a pronoun. Yes. Okay. So it's a word that refers to, pro meaning for. Okay. So it's like pointing to. It's for this other noun. Okay. So this is just a pronoun, which means it's referring to some noun that's in context. If there's no context, then it doesn't make sense. Okay. Now, if you do say something like, this is interesting, or this is a fine day, then the context is there. You know, when you say this is interesting, then they're like, what's interesting? Okay. You're basically referring to something that hasn't been given context yet, but the person that's listening knows that there is a context that you're referring to, just hasn't been spelled out yet. That's kind of how the this keyword works in JavaScript. So what it is basically a pronoun that's referring to a specific object. Which object is it referring to? Basically, you have to look which object is it inside of, okay? So the first few ways that we can bind the this keyword, and binding is what we're calling it when we're saying that, you know, it's like if I say, you know, the cat that's next to me is a really old cat. This cat is 13 years old or something. That's saying I'm binding the this pronoun to my reference to the cat. In here in JavaScript, we're using this keyword, and we're just giving you 4 different rules that you can remember for how to figure out what this keyword is a pronoun of. Okay, what noun is it referring to? Specifically, what object, what JavaScript object is it referring to? Okay, if you just say at the global scope, console log this, what's going to happen? What is this referring to if you say just this on the global scope, not inside anything else? Not inside of a anything else. Okay, it's going to be the window or the global object. Okay, so that means it's going to bind this keyword to the window. So let's see how that works. Okay, so if we just do, if we just go in here and then we just say this, I think we can even just do that. And then, boom, what's the output? The output is the entire window object. And how huge is this window object? Really huge. It's still going. It's still going. It's not small. Done, okay? Not infinite, not infinite. And guess what it ends with? It ends with, same as all the other objects in JavaScript, the prototype. Okay, so we'll get to the prototype after the next break, but basically, look at all this stuff I got to clear out. This is all stuff that was printed with the rest of this code here. So just remember that. Try not to console log this at the global scope. It will just return the window. Do you want the window cluttering up your output? No, you do not. You want to return things. If you're going to return the window, might as well return one property from the window, not everything. Okay, do yourself a favor. But that's how it would happen. Okay, if you console log this, it's going to be the global scope. It's not going to be good. All right, how's the second way? This is implicit binding. When I say this phone right here, referring to things that I can reach that are kind of within range of my arms, right? Or anything that's kind of in this space. When we use the word that in English, we're talking about stuff you can't touch. Can you hand me that bottle over there? You never say, can you hand me this bottle over there? You could, but it doesn't quite sound right. You have to say that bottle over there, okay? Because it's outside of the range of where you can actually reach. This is referring to objects that you can actually reach. So why? Because it helps with the context. So in the case that you use the keyword inside of a function that's part of a property inside of an explicit literal object like this, what is it referring to? It's referring to the object that it's inside of. How do you know that? It's just implied. That's what implicit means. It means it's just the normal way, the regular way for it to be connected. Technically, the window binding, the global binding, is also a form of implicit binding. It's just this keyword is referring to the context, okay? There's this mimetic way of using the word this when you're just saying like, I'm not a fan of all of this, right? And you're not referring to anything specifically, you're just saying everything that I can see and touch, right? So this is referring to the object that it's inside of. And that's really always what this is going to refer to. It's just referring to the object that it's inside of. But with the next example, we're going to see something where it's not actually inside of an object yet. It could be in the future, but it's not yet. So it's like when you initialize a function, you declare a function, you put some code in it. Does that code get run yet? When you create the function, you haven't invoked it yet. If you don't invoke a function, does that code ever really exist? No. From the perspective of the code, of like a JavaScript file, that code doesn't really exist unless it gets invoked. Okay. So we're going to do something similar. All right. So our first one was the global, and our second one is the implicit binding in a named object. Okay. So an unnamed object is the window. A named object is some custom object that you make. Give it some explicit, key value pairs. Key value, all right? So there's a key value pair right there. I can even collapse that. You can see that a little bit more easily, right? So you can have a function as part of a property. And what is that called? What is it called when you have a function as part of an object property? We've gone over this. What is it called when the function is part of the object as a property on the object? There's a specific word for it. Map is one of them. For each is one of them. It's called a method. Yeah. So you're like, hey, how does map and for each work? They work like this. Did you know that? They work exactly like this. So you could literally, if this were, you could literally do that, say map, and then give this function, have this be a for loop, for, key in array push. Well, what this basically does is like it initializes some array in memory. It doesn't really give it a name, right? Okay. So this is basically what's going down, what's happening when you have that map array method, that dot map. That's what it's doing. It's doing something similar to this. It's giving you, it's putting an array in memory, new one, and it's pushing, each of the values in the array one by one. So that's the way that map works. It is simply just a function set to property, and the name of that property is map. The value of that property is the function that executes the map. Okay. So that's all there is to it. And then specifically what you do is you pass it a callback function, and then you define that callback function. But yeah, so remember that you can invoke, when you have a method, you can invoke it like that, like dot notation. Doesn't this look the same as, some array dot map? It's the same, right? This is simply a property of an object, and it's called a method. So this would be an object method, this would be an array method, but they operate the same exact way, because it is a function that's being set to the value of some property on the array. And technically, it's on the array's prototype, which is an object. Okay, so that's the implicit binding, and then we get to this new form of binding that I was mentioning. Okay, what do we have here? Okay, we've got curly braces. This could be an object, right? But then we don't have the colons or the commas. What is this? Oh, it's just a regular function. Okay, it could be, with lowercase c even, and it wouldn't be like broken. But what happens here is we give it a capital C if we want to use what's called a constructor syntax. It's not, like I said, the JavaScript interpreter is not looking at that and being like, look, there's a capital C here. That's kind of important. Not really. It's mostly just a human convention, just to set these apart. And what that is makes it a constructor function. A constructor is basically like a little factory. It's a factory where you have a blueprint. That's what the prototype is, like a blueprint for the product that you want to make, whatever object you want to make. And then the object assembly line goes like this. We're going to add a greeting to the object. Okay, from raw materials, we're going to construct a greeting, and we're going to make that a fixed. Here, we're just going to give it a static string. That's kind of like saying, okay, all of the toy cars that we're going to make have the same exact chassis. Okay, so really they're going to have like the same axis in the front and back axis, and the wheels are going to look the same, and you're just going to put new stuff on top of it. All right. So then on that assembly line in this constructor factory, we're going to add a greeter also, a greeter property, and that is going to be passed in. Some value that's going to be passed into there. Could be a string. Okay. And now we're going to, so that's going to get passed in. So that's going to be custom for whatever runs that factory, that constructor. All right, one more. We're going to add a method on here. It's going to be a speak method, and it's going to console log the greeting and the greeter, and then console log this. We're done. Okay. So here we go. We've got Jerry, and then new cordial person Newman. So here's how this is going to work. We have this special keyword called new. So let's jump into the new keyword. I know we've got it around here. There we go. All right, so here it is on MDN. The new operator lets developers create an instance of a user-defined object from a constructor or one of the built-in object types that has a constructor function. And here's what it does. It creates a blank plain JavaScript object. It links this object to another object and then passes the new object from step 1 information as the this context, and then returns this if the function doesn't return its own object. All right. So what it's saying is when you say new, it's like going to this factory and saying, all right, I need to make a new cordial person. All right. That's what I want today. I'm going to place an order for a new cordial person. So we're going to require a new one to exist. So let's run this function that's going to create one for me, and let's pass it any of the information that it needs. Okay. So let's jump back up here. You can see right here. Okay. And then I also had that console logging the entire object. So there's a little bit less busyness up here. Okay, so here's what you have. All right, you're going to pass this in, and then it's going to, okay, so Newman's going to go into greeter. Why don't we go through this like step by step? Okay, so let's take this and put it into our JavaScript tutor. Let's go to our JavaScript tutor. There we go. So we can figure out what exactly is going on here. Let's visualize this execution. All right, how many steps do we have? 16. All right, don't get overwhelmed. It's pretty simple. First step is we define this one function. So it's on the global frame, this cordial person function, and it has these different properties. All right. This keyword in here is going to say, all right, whatever object I eventually have from this factory, give it a greeting property, and then give it a greeter property, and then give it a speak method. Okay? That's what this keyword is doing. It's saying the plans are in place. This is what the assembly line will do, but it hasn't done it yet. The new keyword says, do it. All right, do it now. All right. So next, we save Jerry in there. There you go. And we actually execute it. So what we did is we executed this, and we ran this core person. So it created this new object with a greeting, with a greeter, and with a speak. Did it actually run? Did it invoke that speak method? No, it did not. It just initialized it. It just created an object, a literal object, with these 3 key value pairs: greeting hello, greeter Newman, speak, and then this function. The function basically just console logs this greeting and greeter to the output. All right. And then same thing with Newman. Okay, so we're going to initialize that code. Now we're going to run that function. Well, we ran the function with Newman, we ran the function with Jerry. Now we're going to run the method that's inside the function. Okay. So now you know of 3 ways where you can do functions inside functions. One, you can do closures. Another, you can do callbacks. Another, you can do methods. Okay. With methods, what is it? A method is when a function is the value of some property in an object. But this isn't an object, is it? Not like in the most literal sense. This is a function. What does the function do? It creates objects. All right. Or really what this is this defines the kind of the blueprint, like the architecture, the designs of what that object is going to look like. And this new keyword is creating that object. It's saying, all right, I want to run this template, and I'm going to pass some information into the template to customize it a little bit. That's how this works. Okay. So it's going to add these pieces on to the new object. You can see that object being built. Greeting, greeter, and then speak. All right, so it has those pieces in there. And now what are we going to do? Okay, Jerry's going to speak. What do we expect is going to happen here? Okay, so we have Jerry. He's a new cordial person. We're passing in greeter. Okay, so it's going to be hello, Newman, and then we're going to speak that. Greeting, hello, Newman. All right, so let's try that. Boom, it worked. Okay, what did we do? We invoked the method that was inside of the new object that exists. Okay, so Jerry exists by this point, so does Newman. Do the same thing with Newman, and he's going to say hello, Jerry. Okay, there you go. Now it's done. We're completely done. All we had to do was define this constructor, okay, a function that can create objects, and then we say, hey, run that function that can create objects right now. And then what it's going to do is use this keyword to build that object bit by bit. Greeting, greeter, speak, etc. All right. So yeah, now what happens if we console log? If we console log Jerry, for example, let's just see what happens. All right. We had that in here before, but we don't have it in there right now. Okay. I think we might have it down in here somewhere. All right, well, I had it here, so I'm going to go ahead and hide that and run it again. And now you'll see them stuck in the middle here. There you go. All right. So this object right here, console log this. It's an object. It doesn't give you the name of the object right here because it's getting created here on this side of the code. It hasn't yet been assigned. Okay. And we're going to have a greeter, Newman, a greeting, hello, and then a speak function. And the speak function looks like that. Okay, greeting plus greeter. Doesn't that look familiar? Looks exactly like that. Interesting. We have an object that looks exactly like it's supposed to, based on the plans. Okay, so the constructors are basically the plans to make the object. And then the new keyword says, all right, let's make it. And this keyword is basically, how do we make it? Okay, how do we affect those plans? What are the lines of code? It needs to have this property, it needs to have that property, it needs to have that property, etc. Okay, so good on that so far. That's our third one. Our last one, okay, let's double check our time. Perfect, okay, perfect time. Our last one is explicit binding. What this means is you can use call or apply, and the only difference is apply will accept an array, where call will accept a series of parameters. These are doing our explicit binding, okay? So not just this type of new binding, but explicit binding saying, I want to apply my Jerry object, I want to apply all of its properties to the Newman object. And that's what we're saying here. It's saying go into Newman and then run my code instead, run Jerry instead. Okay, so what is that going to do? It's basically just go in reverse, and then it's because we're telling it to look for the dot speak. All right, so run Jerry's speak function, but run it on Newman. Run Newman's speak function, but instead of running it on Newman, run it on Jerry. Okay, that's what the call and apply are saying. It's saying You know, I'm going to tell you exactly what the this keyword is referring to. That's what it's saying. Apply the this keyword that was used to build Jerry, apply it instead to something else. Okay. All right, and then I have another example of constructors that we'll get into right after the break, but I think that's a fantastic time now to kind of cogitate. All right, so let's review real quick. And I know I have another code pen for this. So I'm gonna find that one. But while I'm doing that, you can see basically there are just these 4 types of binding. All right. Let's quickly reply in the thread. What is the first one? It's right there. It's your freebie. What is the first type of binding out of the 4? Okay, global or window binding. What is the second one? Also freebie. It's also there. What is it? Implicit. And implicit means that it's just literally referring to the object that it's inside of. And you're mainly going to find the this keyword inside methods. Okay, so where they're part of functions. Okay, what is the third one? What is the third way to bind the this keyword to an object that doesn't exist yet? Yeah, we're going to use the new keyword to make that object exist, and so it'll have those features that the function says it's supposed to have. Okay, that makes sense? What is the last one that we talked about? We went through it pretty briefly, and I can go through more examples. But basically, we are going to see lots of examples with inheritance. So it's called the explicit binding. It's saying, yeah, this has applied to this object. Apply it to that one over there. Okay, take my code, run it on another object's data. Yep. Yep. So the difference is really just like the last thing that's in there. With .call, you create a sequence of parameters, and with .apply, it's almost the same. You just use an array instead. Okay. All right, that's enough time right now for that. So let's go ahead and break again. 5 minutes down now. Okay. Be right back. Okay, here we are. Let's wrap this up. Let's see if there are any questions. Yes, there's a question. Yay. What's the difference between call and apply? And when would you actually use them? Okay, great question. Let's jump to, I know I had a specific reference to that. There we go. All right. And that's bugging me. That's better. Okay, so the apply method. With the apply method, okay, what you're going to do is you're writing a method that can be used on different objects. That's what that does. You're saying, okay, let's use this thing that's going to apply my code to other code. It's similar to the callback method. You're basically saying the methods that are in my function or in my object. So the functions that are tied to my object's properties, go ahead and apply them on the data from another object. Okay. So, for example, you're going to have, let's just say a person, okay? And this could be a let, of course. And there's going to be a full name method on this. Okay, there's a method built in here. Okay, so there's a function inside an object. And what that's going to do is it's going to return the first name with a space and then the last name. And you could also obviously interpolate this if you wanted to instead of concatenate. And now we've got this other object, okay, this second object. This one just defines the first name and the last name, okay? So you can apply person's full name function to person one's data. And that's going to return Mary Doe, okay? John Doe. All right, remember you can also, you could also, if you chose to, you could do this instead. Totally fine to do that, like that, and then that. There we go. Boop, boop. And boop, boop. And there, if we run that, same thing. Okay, we can change this. You can see that it's actually working. Mary. Okay. So you can interpolate or you can concatenate either way. But what's happening here is this object's methods are getting applied to person one. So this is the same as if you had this defined on person one, okay? You had it defined there. And then this code is like, hey, what are you doing? This is like broken. Yeah, it's like not happy about that. So instead, let's change this to person one dot full name. And there we go. There's it's mad about something. Clearer. So let's see, why is it so angry? Anyway, you get the idea. Like this would be more simple for it to do. Oh, I think there's something like one too many things happening here. No, anyway. There, oh. Okay, all better now. All right, so this would do the same thing, right? I was missing a comma. Thank you, Joseph Johnston. So there you go. Okay, you can see that this is the same thing happening, but why, obviously, would you do it this way? Okay, for one thing, because you can have methods already on one object and then just apply them to a different object. All right, so you just say, I want this method, I'm not going to move this method to this other object. I'm just going to, one time only, I'm just going to make it happen on that other one. Okay, so that's what's going on here. Call is the same. The difference between call and apply is very simple. The call just takes arguments separately. The apply method takes arguments as an array. Okay, so I actually have a better playground that I forgot to put in my Google Keep. And I'm going to put it in right now. So this is going to be a better playground for instructors. And this is called JS3 Playground, but that's not accurate anymore, is it? No, it's not. So instead, we're going to call it JavaScript. We're going to call it prototypes Playground. How's about that? Who wants it? There we go. Prototypes playground. There we go. All right. Hey, look at this. We've got some good notes. Let's copy that out. There you go. Check Slack. I put it in Slack. Give me some reacts on that. Here's our review. We have this parent refers to the parent object. Okay. Window binding is global. Implicit binding has a declared object. New binding uses the new operator, okay, with a constructor function. And the explicit binding uses call or apply to specify the other object that you want to run the current object's methods on, okay? And you can pass any other additional properties than you want, anything. Okay, you can pass additional arguments in. They could be defining other things. Okay, ooh, that's a preview, that's a secret. So in this one, I also go through global and implicit and so forth. There was another question. All right, so there's that. Why did you use console log this? Well, what that does is it does exactly what you'd expect it to do. It puts in the console, it prints to the console the parent object. That's what it does, okay? So if you go to here and say, for example, console.log this, and then save that. Okay, what is it going to start with? It's going to start with this. It's just going to print out the object that I've explicitly created here. So this is my object right here, name Shooter McGavin, and then say name function. What does it have in there? It just has this function, all right? That's what console log this does. On the global scope, it's going to print the entire window. And that's not great, okay? We don't want that. Okay, so that is that. And okay, so the new binding, here's another example of the new binding, so it makes a little bit more sense. Picture, okay, you got a cup factory. And this cup factory requires you to input certain things like, okay, maybe an e-commerce store. You go online, hey, I want to buy this really cool cup, you know, for a friend of mine. but I got to choose. I got to choose the color, the shape, the handle. And I'm going to pass those values into the properties so that once that object does exist, it will have those values. All right, so I want a new blue square cup with a handle, like this one, except blue. Okay, this one is like a, I don't know, like a periwinkle or something. Maybe a persimmon. So there we go. So you're saying, this is just saying, I want a new object. What kind of new object do I want? I want it to follow the cup pattern. And so the cup patterned object, I'm gonna pass it certain custom information so it can be a little unique. Okay, so it can be special. And then if we console log just the shape, we get square. Okay. Explicit is saying, all right, I've got this object right here. It has this full name. I'm going to pass it, and here's the same example we pulled from W3 schools. I'm going to apply this method or call this method on, like it's saying, all right, full name, I'm going to call you out on person 1 and person 2. Okay, so it does it in person 1. What do you get? John Doe. Okay, call method just takes arguments separately. The apply method just takes them as an array. That's the only difference. All right. So here we go. There's one more question here. For call and apply, do they have to be in the same scope? I mean, they don't have to both be, you know, you don't have to say both of them, right? You can choose which one. But if you're saying, does it have to be in the same scope? Same scope is what? Obviously, if something, rule of thumb, if something is going to work, it has to be in the same scope as the data that it needs to apply to, right? If for some reason you had some object and it was just impossible to get to it because it wasn't available in memory, then no, it wouldn't work. So they need to be in the same scope. When using new, does it have to be stored in a const? Very good question. Let's see. Okay, so I have a new down up here. It doesn't have to be stored in a const. Why do we do that? Why is it kind of nice to store it in a const instead of in a let or a var? What does that prevent us from doing? So like, for example, you know, cup1 equals, let's edit it. Let's edit it. Now let's say cup1 equals 5. Let's just see if it freaks out. Okay, assignment to a constant variable. So all that does is it allows us to, you know, all that does is it allows us to do that, you know, prevent us from overwriting our object so we don't accidentally lose all of our data. Because objects, as you've seen from some of the assignments, can be pretty big, right? Would it be cool if you just like deleted all your data accidentally because you forgot to change the name of your variable? Not fun. Yeah, so use consts until you can't, and then use lets until you can't, and then use vars never. There we go. So it doesn't have to be stored in a const. It's just a good idea for objects to be stored in consts so they can't be unobjected. Okay, if you de-objectify them, then they're no longer objects and they're not fulfilling their true purpose. Okay. So here's and a follow-up to that question, meaning does it need to be stored in any type of a variable? Well, yeah. I mean, it's data. Technically, no. It doesn't have to be stored in a variable. You can just pass data around completely everywhere. But what if your But in order to use anything from that object or reference anything from that object later, you would have to print out the entire object again, which could be very problematic, be very, very difficult. So in order to reference a specific key or a specific value inside an enormous object, it's best to put it in a variable. The variable is a shortcut. It's a nickname. And then using that nickname, it's kind of like a pronoun, you can refer to a specific piece of the puzzle. And that's kind of what the this keyword does too. The this keyword is kind of like a variable too, but it's a variable that is just always defined as whatever parent object it's inside of or will be inside of, okay? All right, so rule of thumb, if you have data and it's important data, put it in a variable somehow. Just do yourself a favor and save it for later, okay? If you need it, just in case, all right? So that's those are the 4 bindings, and we are moving on to a better instruction on constructors. So now with constructors, we are going to talk about constructicons. Now we are going to talk about transformers. So how's this gonna work? Now we're gonna learn about this inheritance thing that we were talking about and how prototypes work. Okay. So let's start with this. Transformers. Okay, so I made a constructor called transformer. This is going to be a factory that makes objects that follow the transformer pattern. Okay, no objects exist yet. All I've done is just like any function, I've just declared a function, that's all. Doesn't matter. And you could have any amount of code in here. You could have regular code. You know, you could say regular things like, you know, const num equals 5 and then do more code. That's totally fine, but constructors are kind of like, the point of constructors is just to build objects. So to keep it simple, all of our examples just have lines that have this and then some property name you want to define and then some value that you want to assign to that property. Okay, so just think of how the CSS looks. You have font size and color and all that. You have these properties and you have values, just the same way. That's how JavaScript objects work too. Okay, so we're going to give him a name, we're going to give him a faction, we're going to give him a catchphrase. So let's give him, let's create a new transformer and say Optimus Autobot rollout. All right. So let's console log that catchphrase right up here. Let's console log the entire object. That's what we get right here. Okay, you can see it's an object with these 3 properties, keys, and values. Okay, and what did it do here? It put them in a different order. What order did it put them in? It's nothing really that important. The order doesn't really matter a whole lot. All it did is put it put the properties in alphabetical order. Okay, doesn't mean a whole lot. There's no real order to objects. It's just an easy way for it to print out on the page. And it just shows you that the order that you put these properties in doesn't really matter. Okay. All right, so we got that one. Now, how do we add a property to this? How do we add a property to this prototype? Okay, we can't just add a property to the function that creates the objects the same way that we can with the objects themselves. So like I could do this. I can do this. I've got an object. I want to add a property to it. I can totally do that. That's no problem at all. I can do that. And then if I want to console log tf, then you know, clear that out, run it. That'll give tf1 that height. Okay. You can see it doesn't have the height here. It does have the height here. That's fine. But doing this won't apply this new property to the constructor. It only works on this one object that I made from the constructor. How do I apply it to the constructor? Well, guess what? It goes on the prototype, okay? So instead of just affecting one object, we're going to affect all the objects ever made by this constructor. Great, that's what we're going to do. We can also do that with methods. So we can add a property that has a function attached to it, so it becomes a method. And then we got this calc power, all right? So we can do that, and then it will build on this, this calc power, and we could do, for example, calc power. Let's try that. Okay, so that's going to return that. Let's just see what that does. Let's see if there are any issues with it. Okay, looks like it's not a number. All right. Oh, you know what? It accepts the parameter that I didn't give it. Let's give it 2. All right. So what should we expect? What should we expect the final number to be? 60. Okay. There we go. So here we go. 60. It did 2, passed the 2 into here, and then did 2 times this height. What is this height set to? 30. Okay. So you could use that as kind of like a baseline and then adjust it accordingly. All right. Now let's do some inheritance. Okay. Very, very simple. Let's make a child version of the constructor. So what that is, we start out with, all we do is we create another constructor, all normal like, okay, nothing special. But we're going to copy the parent's properties to the child, okay? Remember how it worked, how .call works? You take the parent and you do a .call to apply the parent's properties with the child. So you apply the methods from the first one onto the child. So we saw doing that with .call, where you could just literally put .call on an object and then apply a specific method to another object. In this is pretty cool. We're actually putting it on the constructor, not on the object. And that way it'll copy everything. It'll take all of the properties and methods from the parent and it will apply them to this. What's this? Any object made from the Autobot child constructor. Okay, so this is a child. Why is that? Autobot is a subset of all transformers. I didn't put it on here. Pop quiz. What's the name of the other child of transformers? The major one. What is the other thing that are not Autobots, but they're also transformers? Okay, Decepticons. So I could write another one. All right, well, so I could, obviously I've got Bumblebee down here. Bumblebee is a new Autobot. He's named Bumblebee. He's an Autobot. That's his faction. And he goes, bzzz. So that's what Bumblebee does. But if we wanted to, we could make a different thing. And instead of, so here's another child constructor. So this one can inherit from the same parent, okay? We could call this one Decepticon. And they also have name, faction, and catchphrase. They also inherit everything from Transformer. And this one, their alignment is going to be bad. All right, what are we going to do? Pick a favorite. All right, well, we're just going to do the big one. Megatron. Starscream is the first one I was thinking of, but I can't think of a catchphrase for him. He probably has like plenty though. Decepticons. And then, no. That would be fun. I'll get you next time, Optimus. That sounds like something that Soundwave would say though. Anyway, not Bumblebee. Let's do Megatron. And then we'll do console log Megatron. Yay. Alrighty, there, that works. So we save, and then we run. And what are we getting there at the beginning, at the end? All right, I'll get you next time, Optimus, Decepticon 30 Megatron. Okay, so this dot alignment. And ooh, what's wrong here? It says alignment bad. Let's see, did we mess something up? This is fun. Oh, look, I didn't change it here. Decepticon. Now we're not using, see, notice that? I was actually making Megatron an Autobot. That is heresy of the highest order. All right, now he's proper. He's bad. Okay? Because I initialized the child, and now I'm going to use that child. Okay? So here's our, oops, here's our second child right here. Notice the similarities between that one and this one here. Okay? The Autobot one. Everything's basically the same. All right, I gave it all. They don't. This right here doesn't have to be the same. Like this could have an extra property. Like I could give this one like a this dot flying equals true. You know, because there are far more flying Decepticons for whatever reason than Autobots. See, if I do that, Decepticons get to fly, but Autobots don't get to fly. Okay. Cool. So that's how these work. Basically, I agree with you that this is a lot of work. There's a lot of words here. There's one thing I didn't go over. Okay, we went over the first step, which is to do the dot call. But the second step that you need to make it so that the prototypes match up is you need to create the child and set the child's prototype, which would otherwise be its own. You have to set it equal to a new object of the transformer prototype. Okay, so you're creating a new object with the transformer prototype, copying the parent completely, and then it will add the additional properties that will be only it, nothing else. Okay. All right. So that's basically it. That's basically it right there. Now, there's a child constructor. Yeah, so to reiterate step one to doing inheritance is to do dot call or dot apply on the parent's properties. And step two is to do this. Okay, you take the child's prototype is equal to a new object of the parent's prototype. Okay, so you might not understand how that all works on the back end, but basically this is required. This step is required so that it can have everything that the parent has. It inherits all that stuff. And then it's saying, yes, you have access to the parent stuff, but can you apply the parent stuff to new objects? That's what this line does, okay? This one gives you permission to use the parent stuff. This one right here applies all that stuff to the new objects. Okay, so that's the difference there. And that's pretty much it. So let me just see if there are any additional questions. When creating methods, is it ever better to create them inside the constructor function, or will adding them onto the prototype always be preferred? That's a really good question. I'm not sure exactly the best answer for that. If anybody has any thoughts on that, then feel free to throw that out there. But basically, what this allows you to do what adding things outside and adding them onto the prototype allows you to do is just have a little bit more freedom there. But it is a nice kind of rule of thumb to just put the static or put the regular properties inside the constructor itself, and then add the methods afterwards. Because the methods are these longer functions, it can make sense to keep them separate just for legibility. But actually it does kind of make a difference in the way that the prototype itself is structured. So yeah, not exactly sure. I'm going to see if I can do some research on that and get back to you on that. Yeah, it definitely wouldn't be super nice to read like a 300-line constructor function. What this does allow you to do with methods and initializing them outside is if you initialize them outside, they just won't, yeah, like I said, there's a difference in the prototypes. They won't be inherited in the same way. So we can take a look at that, but let's also look at that next time. We have a lot less to cover next time. Guess what next class is going to be? It's going to be taking this and doing it with like 20 fewer words. Does that sound good? We're going to do the same thing, but we're going to use classes instead of just simple constructors. We're going to use a different type, basically a different interpretation of it, and then we're going to do it in a lot less words, and it's going to be a lot cleaner and more comfortable. Okay, like this right here being outside, not cool. Like this right here, being outside, it's completely separate. It's not super cool. All right. Okay, so I answered that one. And then let's get to these last few questions, and then we got to show you the project and then be done. Will it be always object.create? No, we're going to get rid of that next class. Yes. We're not going to write it anymore. It's still going to be there in the background, because that's what has to happen inside the code in order to reset the prototype. You need to create a fresh object, literal, like that. You need to create a fresh object and then create a new object from the parent's prototype. So that's always going to be necessary. It's always there, but next class, we're not even going to type it anymore. We're going to find a way to get around it with a single word. It's going to be cool. Okay. So that's a good question, but we're going to not have to use that in the future. So the syntax like this: apply equals transformers dot apply this name faction catchphrase, call transformers call this name faction catchphrase. So the difference, it's actually going to be a little different than that. It's going to be, let's go to it. So if it were apply, it would basically be transformer dot apply this, and then parent args, and then this would be an array. So instead of, or it could be an array or an object, it doesn't really matter, but that would be the difference. Okay. So this is the way apply would work. You could pass it in an array, but technically, like, it's funny because like you can still kind of do that with call anyway, because obviously this could be an array. But what apply does is it kind of forces it so that everything else is an array. So it wouldn't work if you had something else after it. So that's what apply does, is it kind of forces you to keep this line simple. Because what if I had 50 other things right here? Like, that'd be kind of messy. So that's why we do pass in objects and arrays instead of just doing it like that, like a set of strings. Okay. So that's how apply would work. Okay. All right, well, let's just do one last review of everything. This is basically going to be the one sheet that you'll need to just review today. We've got the 4 types of binding to this keyword. If you don't do anything, it's going to be the window. If you do something and it's inside an object, it'll be that object. If you say new, it's going to be whatever new object gets created from a constructor. And if you say call or apply, you're saying I want to apply a previous object or a previous constructor's properties to a new one's. Okay, that's what those are. And then constructors basically uppercase letter. Okay, a series of properties and methods that get defined inside the constructor, passing in whatever data you need to pass in. It could be all static. You might not even need any parameters, but normally you'd have parameters. And then, because otherwise all the objects would be exactly the same. That wouldn't be great. All right, and that's how here's how you initialize it. You use the new keyword to create a new object from the constructor. All you're doing here is invoking a function. It's just regular old JavaScript, invoking a function. But in doing so, it creates an object. All right, because it creates an object from that, and then you can store that in a variable, then refer to it later. And then you can add properties and methods to a prototype. So to add them to the constructor, but you have to use this prototype keyword to do it. It unfortunately won't let you do that. It won't make sense to it. Okay. There we go. And then, okay, so that's our parent right there. How do we get our children? We say 1, allow my child to copy from the parent. No, 1, copy the child's prototype from the parent's prototype. And then 2, and I've got these out of order, but they're in order in the code. Allow the, go ahead and push all of the prototypes, all of the code from the parent into the child. Okay, using the new, using whatever new properties and arguments you're going to get passed in for the child. Same thing, you could do a sibling, you could do a separate child constructor. It doesn't have to be all like that. Just like how in HTML you can have 5 divs on a single, in a single section, or 5 paragraphs in a single section. Okay. All right. So are we good mostly on this keyword? Ready? Are we pretty much good on this keyword? Give me some thumbs for that. Or any other reply. Okay. Any reaction at all. Doesn't matter. All right. Are we good on the new keyword? We're good on that. Basically, it's going to allow you to create a new object from a specific constructor function. Okay. All right. Are we also good on? Now this might be a little trickier. You don't know the whole power of what this can do yet, but are we basically good so far on the prototype? The prototype is basically the skeleton of the constructor function, and you can add things onto it through that prototype. Okay, that's what you need. All right, cool, fantastic. Okay, someone planting that question. Will these work with functions? No, they will not work with arrow functions. If you want to know why, we are a bit short on time, but there is something in here that will explain it. Let's see if we can get to it real quick. So why won't this work with arrow functions? Let's see, arrow functions. Okay. See if it mentions it on the constructor. There we go. So with prototype methods, they won't work with arrow functions because it's it's well said in another place. We try to be cool. We try to be a hotshot by using an arrow function, but we don't use it because we need the keyword this. So you have to use a regular function. If you do use, I think it's because the this keyword is bound to the nearest object in regular functions, but the this keyword is kind of bound to the function in arrow functions, so it's a little bit different the way it acts. So you can't use arrow functions the same way. It's something about it being like asynchronous versus not asynchronous, but yeah, so there's an issue with it. So don't use arrow functions when you're using the this keyword. Okay, it doesn't bind to objects the same way that you would expect it to. All right, and that is, here's the link for that. Okay, and that's one of the questions that was asked. Cool. When creating a child, if you pass this, would it have, if you passed this, would it have the same effect? So that's kind of what's happening. So when you create when you're creating the child, are you saying when you're using call and apply? Go ahead and put it in the thread if you need to clarify that in the Slack thread. If you need to clarify that further. But basically, if you pass this, that's what this is doing here. This has to be right here. This is saying I want to apply all of the parents' properties and methods onto any new objects that I create in this function right here. Okay, and you can obviously override those with any other properties that you put in. So like I could go in here and say, all right, this parent has a calc power function or a height function. Let's take that height and let's change it. So I could go in here and I could say this dot height equals 40. All right. So notice that before it was 30 because it was inheriting that from the parent. But if we save and run it again, then Decepticons will be 40, whereas the sibling and the parent are still 30. Cool? So yeah, basically you can, that's what you need is this right here is saying all those methods and properties from the parent, let's bring them to the child. All right. And and this specifically is tying it to any objects that it creates. This is tying it to the prototype of the constructor. Okay. If you just pass this and nothing else, well, first of all, what are you going to do? You're going to ignore all of the, you're kind of ignoring the rest of the parameters that you're passing in. So if you don't pass these in, what's going to happen? Okay, well, I mean, if we leave it like that, what happens? These get passed into here, okay? But how do they get used? They don't, okay? They won't get used, and so, even just passing this right here in, these need to get used somehow in the code block. They need to get referenced in the code block for them to work. So the answer is no. If you only pass this right here, but you don't pass the arguments, then the arguments aren't going to matter. So the only way this actually would make sense is if you had it empty, but then what's the problem? What's the problem there? You can't personalize it very much, right? It's not really much. I mean, you can a little bit. There's some children here, but none of this is going to work. Okay, you won't be able to pass any of this information in there because it doesn't accept any parameters. So yeah, you do need to have either a set of items or just one array, an array of items. That could be an array of objects of arrays, whatever. Okay, we are over, and we need to cover the project. But good question. So you do need to pass additional arguments in if you want that child to work. Okay, so let's take a look at this project here. Oh, look, it's called JavaScript 3. We'll have to get that fixed. All right, so we're going to use your knowledge of this keyword, and we're going to use Code Sandbox. Now it says you don't have to, but it's kind of nice. It's kind of good practice to have. What's super cool about this is how automatic these tests are. Learn what these errors are. Google assertion error. You know, like this is something that you want to know. It's a nice little error that tells you what's going on here. It's expecting the answer to be Neo here, but it's not. Okay, it's not doing the right job because right here you have to do that task. You should have a given name. The name's getting passed in. You can see where it's getting passed in. It's getting passed in on this index.test.js. So there's what you got to solve. You got to basically build, looks like 3 different constructors. Okay, not that many. And then you're going to, if you want to see the test, you can always go into test, index.test.js, and figure out what they're trying to get you to make it, right? So they're, and but yeah, you don't have to understand all this stuff like it and expect and equal and describe and stuff. But basically, what you can see is that you can, yeah, you can basically go in here and say, all right, this is what the real answer should be, trains. Now, it's not going to work if you just paste in trains in the answer, but get used to this. Code Sandbox is this is basically VS Code in the cloud, okay? This is a full IDE. You can see all your files. You can edit right here. Here's your browser. If you want to do your console, it's down here. You might have seen this already previously, in which case this is all review, but you won't need to use that tests tab. All the tests are being done in the browser, okay? All right, so, and it'll tell you exactly how many you've passed and failed. So once you hit 100%, you're done. And some of these formulas are a little tricky that they're going to give you. They're going to say, all right, you got to do this thing where it, you know, pushes food in the stomach and then it leaves the stomach. You have, you know, drive distance on your odometer, etc. So go ahead and check that out. There is your project right there. Project. And I just want to thank you all for the awesome questions that you've been giving. Let me go ahead and stop sharing. We covered absolutely everything today, only went a few minutes over. Thank you so much. I've been Pace Ellsworth, your instructor this evening, and I hope you guys have a nice time with this. Getting constructors the first time is a little tricky. It's hard to remember like that they are functions. They're not objects. They build objects, but they are 100% just functions. They behave in the exact way that functions do. All right. But we learned two different types of functions in this one. We learned that you can have constructors that build objects, and you can have functions that are part of objects too. Those are called methods. In fact, all of the methods that we know, you know, are, and in fact, all the properties that we know that are built into things like length, and then you know, parsing, you know, and all of these things that are console.log. Log is a method on the console object. It's on the console prototype. Log is a method. It's a property called log and a value that is doing all of this back end work to contact the console and then push things into the console. It's pretty cool. Okay, so tomorrow, well, Wednesday will be our last lecture together. I'm sorry to say it was fun. I hope that I get to work with many of you in the future at Lambda School. It was really, in fact, last week was the most fun I've ever had teaching. I have to be honest about that. That was really, really, really fun. You guys made it fun to talk about closures and callbacks, and yeah, it was pretty fantastic. So that's it. We'll go ahead and stop right there. We answered all the questions. We've got everything done. So you guys have a wonderful night. Thank you. We'll see you.